can see in my screen share, I just wanted to make sure everybody knows that December 20th to December 11th will be our next meeting, and we are going to be asking members to share some of their best pictures from the year with us. So if you would like to take part in that, please contact Kirsten Jacob. There's her phone number. You can contact her by phone or by text, or you can email her at her email address, which is akirstenjacob@gmail.com. I'm going to leave that up for just a moment while I introduce our speaker. We're so happy to have Julie join us. She served as the botanist for the Shasta Trinity National Forest from 1989 to 2019. That's a long time, conducting rare plant surveys and managing the botany program for that 2.2 million acre federal property. Focusing on the Klamath Range flora of Northern California, she's collaborated on publishing new taxa and biogeographical floristic information. She recently co-authored the book Wildflowers of California's Klamath Mountains. Maybe she'll tell us who published that book and where it's available. Currently, after retirement, Julie is a California certified consulting biologist. She serves on the CalFlora Board of Directors, as well as the CNPS Rare Plant Program Advisory Committee. So she keeps busy. She teaches field workshops in Northwest California for Jepson Herbarium workshop series with co-teacher Heath Bartosh and others. So we look forward to her sharing her knowledge about stark beauty, Klamath-Siskiyou Serpentines. And I will put Kirsten's contact information up again at the end, and I'm going to stop sharing and give the program over to Julie. We're so pleased to have her.
Okay, can you see my screen?
Not yet.
Okay.
Click the share button again.
Oh, dang it. Now I gotta find it again.
Okay.
Here we go.
Perfect.
All right, let's go back. Okay, so you can hear me?
Yes.
All right. Okay, so this is going to be a tour of the serpentine floras of the Klamath Range in northwestern California and into southwestern Oregon, which is a remarkably diverse landscape, and I think, in my experience, is vastly underappreciated compared to, say, the Sierra Nevada, which is okay with me. You know, part of me would like more people to visit and advocate for these plants and this landscape, but on the other hand, it's not overrun yet. So that's not a terrible thing. But let's look at the plants, let's look at the landscape, and maybe some of you will decide you'd like to visit. So the Klamath Range does have a coherent flora, and within that are a number of different geologic substrates. That's one of the things that characterizes the Klamath Mountains, and I'll use those more or less interchangeably. Klamath Ranges, Klamath Range, Klamath Mountains. I don't mean to distinguish by using different terminology. It all means the same thing. One of the notable things about the Klamath Mountains is the geologic complexity. And I'm going to focus on the serpentines, but recognize that there's also a significant component of volcanics and carbonates, such as limestone and marble, sedimentary and metasedimentary substrates, and even some volcanics and a fair bit of granite, intrusive granite. So the Klamath Mountains is not all serpentine, but it has a lot more serpentine than most other places in the world. So left to right there, we have a very narrow endemic of the high elevation serpentines in the eastern Trinity Alps wilderness called Antinarius sawyeri. It's Sawyer's pussy toes, named after John Sawyer, who was a very well-known and well thought of ecologist and botanist from Humboldt State University, now Cal Poly Humboldt. In the middle is Mount Eddy sky pilot, Polemonium eddiense, recently described, I think it was 2015, and to this day known only from Mount Eddy, which is the easternmost mountain in the Klamath Ranges. It was for a long time thought to be a disjunct population of Polemonium cartaceum, which is a plant of the White Mountains in the deserts of Southern California. But recently genetic work indicated that it deserves its own name. The one on the right is an endemic manzanita. Everybody's got an endemic manzanita. This is Klamath manzanita, Arctostaphylos klamathensis. And it's a pretty little thing. It's an intermediate sized glaucous glandular species that, like most manzanitas, doesn't mind a bit of disturbance now and then. So to reiterate, we call the Klamath Mountains the Klamath Ranges. The Klamath-Siskiyou bioregion is another one that comes up. Don't be confused, they're all the same thing. So this is very similar to the Jepson physiographic province map. It just has the geology thrown in. You see the Klamath Mountains there in Northwest are very similar geologically to the northern part of the Sierra Nevada. And the different colors just indicate different geology. So there's granitics and serpentine and metasedimentary and other stuff. You'll notice that compared to the Modoc Plateau or the Cascades or even the Coast Range, it's a lot more complex geologically. So one of the jokes about working in the Klamath Ranges is, you know, if you don't like the habitat you're in, just walk 100 yards and you'll be in something different. So the box up in the upper left corner of this map is the area that I'm going to be speaking about this evening. And you'll see 3 different colors. This is a graphic from the CalFlora database that shows the 3 principal serpentine areas in northwestern California and adjacent Oregon. The purple one, the Trinity ophiolite, also called the Trinity ultramafic sheet, is the oldest one. The blue stuff is the next oldest, and you can see it extends down in the Sierra Nevada. And the red polygons then are the most recent accretions on the edge of the continental plate. So serpentine, what and where is it? I'm showing you where it is right now. We'll talk a little bit more about what it is in a bit. I love this map. I have it posted on my refrigerator. I just think it's pretty. And again, you can see the compatibility of the Klamath Range with the Northern Sierra. And the big, you know, pinky salmon blob there in the Northeast is just all the volcanic stuff that got spewed out and probably covered up whatever connection there was between the Klamath and the Sierra Nevada. So maybe it's still under there, but it's not growing plants anymore. Just to point out that the Klamath Range extends into southwestern Oregon. So the Klamath Range here is not truncated at the state line. It actually extends up in a kind of a triangle. And in Oregon, they call it the Siskiyous. So Klamath-Siskiyou. I rarely run into people in Oregon who talk about this part of the Klamath Ranges as the Klamath Mountains. They call it the Siskiyou Mountains. Here's another view, a different map. There's so many maps, my goodness. But basically this one just shows all of these yellow blobs are ultramafics, which is another term used for the common term of serpentine. Ultramafics is a broader term that includes different kinds of serpentine substrates, ranging from the non-metamorphosed red stuff to the shiny green stuff that we call serpentinite or serpentine. So here, let's see. This blob, again, is called the Trinity Ultramafic sheet. It's the oldest one. It's the eastern edge of the Klamath ranges. This white thing here is Mount Shasta. So Mount Shasta is a pretty good indicator that you're not in the Klamath range anymore. You're in the Cascades. So that's the line. The next big kind of scattered wad of stuff I'll be speaking about is the Rattlesnake Creek terrain, which is kind of an island arc down here in the Southwest. And then this stuff extends into Oregon as the Josephine ophiolite. And we'll talk a little bit more about those words too. So this is a quote from a paper that Hugh Safford and Jesse Miller wrote, which is a paper about serpentine endemism in the California flora. So soils derived from ultramafic parent materials, and the colloquial name for that is serpentine. That's just what we call it. Even if it's not all serpentinite, we call it serpentine. And they account for a large part of the diversity of the California flora. They are difficult to grow on, not only because the calcium-magnesium ratio is upside down, and most plants are evolved to have a lot of calcium available and not so much magnesium. But on top of that, these bedrocks and the derived soils also contain a lot of heavy metals, which are often toxic, in particular nickel. So these serpentine substrates have high levels of native plant diversity. They're not very amenable to invasive plants, which is great, because invasive plants generally like, nicer places, places with some nitrogen, places with calcium. So they're generally able to outcompete other native plants, that is serpentine dwellers, whether they're endemics or they're indifferent. They can survive on serpentine, and that gives them an advantage over the plants that can't. So this is a graphic that I love. How do these serpentines come to be in California, or anywhere for that matter, but in California, let's talk about that. So here, this is a matter of plate tectonics in action. And I'm old enough, probably some of you are old enough to remember sitting in a grade school classroom, looking at a map of the world and thinking, or saying to the teacher, hey, South America looks like it fits right into Africa. And the teacher would say, oh, that's just a coincidence. And then plate tectonics became an accepted thing. And it turns out that, yeah, Africa and South America were once proximal. So now on the coast of California, you've got a situation where you've got an oceanic plate butting up against a continental plate, and when they come together, the oceanic plate then is subducted, which means it goes underneath the continental plate. And when that happens, some of the seafloor from the plate gets scraped off and glued onto the edge of the continental plate. So that's called, the going down is called subduction. The glued on stuff is called accretion. And my favorite analogy was one that Hugh Safford put forth in a talk I heard a long time ago. And he said, imagine taking a piece of pizza, a hot, fresh piece of pizza, and shoving it under a door. And the crust goes under the door, and all the stuff, the cheese, the pepperoni, the olives, all that stuff gets stuck to the side of the door. And that, in essence, is what happens. That is how serpentine comes to be on, stuck onto the continental part of the world rather than part of the ocean floor. These were ocean floor layers that were added to the continent. And sometimes they're added in a relatively orderly fashion, in which case they're called an ophiolite, which is stratified in different layers. And then usually they're all mashed up even after they get accreted onto the edge of the continent. Then there's folding and metamorphosed stuff, and they get tilted up and they get sheared and so they end up not being in a nice tidy sequence. And those messed up things are called terrains. So it's like somebody took an egg beater to an orderly geologic series and just said, here, let's just see what comes out. So I will be talking about 3 different units in the Klamath Range that have distinct floras. Many of their species and plant communities are shared, but each one has its own unique set of endemics, and they are spatially distinct. So the Trinity ophiolite is the one that is at the eastern edge of the Klamath Range. You saw earlier, it's spitting distance from Mount Shasta. It's the oldest, it's the highest elevation. It's got probably the most variety of habitats in terms of elevation and dry to wet and geologic complexity. The Rattlesnake Creek terrain, which is that long skinny island arc to the south, is relatively homogeneous. It's really dry. It's low to moderate elevation. So it's less complicated, but it still has its own unique set of endemics. The Josephine ophiolite is the one that is nearest the coast and extends into Oregon. It has, in terms of climate, there's a coastal influence. So it's somewhat milder and probably gets more precipitation in the form of rain rather than snow. Also has a range of elevation and a good variety of habitats. So I'm going to start with the Trinity ophiolite, which is this polygon here. These are county lines. So this is the northern part of Trinity County. This is Shasta County with Shasta Lake. This is the western part of Siskiyou County. Up here is Del Norte County and Humboldt County, and there's the state line. So the Trinity ultramafic sheet, also called the Trinity ophiolite, is at the juncture of Shasta, Trinity, and Siskiyou counties. A variety of habitats. The thing that makes it really unusual is leaks and seeps and seasonal and permanent streams. Uh-oh, my internet connection is unstable. I hope it doesn't blow it. So here's Mount Eddy looking from the west to the east. So on the other side is Mount Shasta. This lake is Middle Deadfall Lake in Deadfall Basin below the summit. Looking from the other direction from Mount Shasta is Mount Eddy. Now, most people driving up Interstate 5, they're so captivated by Mount Shasta, they don't bother to look in the other direction because, look at this. This is kind of boring compared to looking at Mount Shasta. But if you look the other direction, if you look west from Interstate 5, you will see the tallest mountain in the Klamath Ranges and a botanically spectacular, way more interesting than Mount Shasta botanically. Mount Shasta, I'll just say it, is pretty dull botanically. Geologically and view-wise, it's really nice, but botanically it is dull, unlike Mount Eddy. One of the interesting things about the Trinity ophiolite is because of the place that it's situated. It has quite a strong influence of Great Basin plants because Shasta Valley, north of Mount Shasta, has been open for a long time. There's no obstruction to plants moving from east to west from the Great Basin across Shasta Valley and into the Klamath ranges. But check out the size of this mountain mahogany. I'm sitting on it, for scale. Some of these mountain mahoganies are 800 years old. They're just phenomenal. So ultramafics is an umbrella term for a variety of different rock types. The two principal ones are serpentinite, which is the shiny blue-green stuff, or peridotite, which is the not shiny reddish stuff. The serpentinite has been metamorphosed, and so it's been under great pressure, and in the surface of the rocks are glassy and shiny, very pretty. So here we have peridotite here near the trailhead to Mount Eddy. This is serpentinite, an outcrop. This is serpentinite, a high elevation barren. And then here you've got a mixture of peridotite and serpentinite, which is not uncommon. As I say, the geology's been so mixed up that that things are juxtaposed that would not have been if they were intact under the sea. The wetlands are interesting in the Trinity ophiolite. There are large expanses of wet meadows with embedded fens, and fens are places with peat buildup, and they have a particular set of species that lives there. There are also these hillside seeps or hillside meadows that have constant subterranean flowing water, but they don't have peat buildup. They just are, they're always wet. These big flat meadows with Darlingtonia. The yellow thing is Helenium bigelovii, Bigelow's sneezeweed, and they're surrounded by a montane mixed conifer forest with lodgepole pine and several other species of pine. High elevations in the Trinity ophiolite get up to, this is the last bit of trail up to the summit of Mount Eddy, where there is a nice population of foxtail pine, which is known from the Klamath Range in several high elevations. And then it hops all the way over the rest of California and reappears in the southern Sierra Nevada. So that disjunction is pretty interesting. The backside of Mount Eddy, here's peridotite, this nice reddish stuff, it is high enough to have white bark pine. This is western white pine. This photo, whoops, is the Upper Trinity River, which is one of the main river systems that drains the Trinity ultramafic sheet, the Trinity River, and then this is the South Fork of the Sacramento, which drains through this rocky serpentine landscape and then hooks up with the Sacramento between the town of Mount Shasta and Dunsmuir. And the tree, it just blows me away how the trees just grow right out of the rocks here. So let's go through a few of the endemics. This is by no means exhaustive, it's just a selection. Antonaria sawyeri, the one we saw in the opening, grows in basically one place in the Trinity Alps. It was discovered and named within the last decade. It grows right near this is the contact zone between the Red Alps, which is the Serpentine Eastern Trinity Alps, and the White Alps, which are the granitic Alps, which are the rest of the Trinity Alps to the west. You can see here, this is a CalFlora image, Trinity Lake, Highway 3. This is Antonaria sawyeri here, growing on the purple ultramafics. It's a dioecious species, which means that any given plant is either female or male, but not both. So I guess these up top, those are the females, these are males. The climb up there to Stonewall Pass where these things grow, it's a bit of a death march, but it's worth it. Klamath manzanita again, which grows in a montane mixed conifer forest setting, very glandular. Interestingly enough, it always grows sympatrically with greenleaf manzanita, Arctostaphylos patula, and Arctostaphylos nevadensis, the pine manzanita. So it's intermediate in size. Neither one of them is glandular. I don't know what's going on. Nobody's done any genetic work to try to sort that out, but I do think it's odd that the other two manzanitas are always present. One of the prettiest buckwheats is this Trinity buckwheat, Eriogonum alpinum, and as the name implies, it grows in subalpine or alpine environments, always on serpentine. You can see it's a little thing. Another relatively recent one, Erythronium citrinum variety Rodrickii, is a fawn lily. It's different than typical citrinum in that it has purple anthers. Now, erythroniums in general are, someone who works in erythronium described them to me as promiscuous, which means they don't care who they breed with. So it's iffy to describe a new thing based on something like anther color, but this one made the cut. It has a name. You can still find intermediates with other things on either side of it, but it has a relatively narrow distribution. This outlier you should probably ignore because flora is just full of things that are mistakes, either mapped wrong or ID'd wrong. I love this plant. I think it's it was when I learned it was a Phacelia dalesiana, Scott Mountain Phacelia, and later it got put into its own genus, Halolanthus. But it's just such a delightful little mat forming thing with big flowers, big purple anthers. And you can see here, it's growing in the median of this dirt road. Likes to be disturbed, but not too often. If it's not disturbed regularly, it will be outcompeted by shrubs very quickly, and it will wink out until the next fire comes through or the next ground disturbance. Pickering's Ivesea is in that group with Iveseas and cinquefoils and in the rose family. So it's got the typical 5 petals, 5 sepals, multiple stamens. And Iveseas have these really interesting 3-dimensional leaves. They look like little, mouse tails. They're cylindrical in cross section with many, many tiny overlapping leaflets. This one grows in seasonally wet swales in woodland that is composed of incense cedar and Jeffrey pine with an understory of grasses and sedges. So in the springtime, this will be very, very green, but by the time this thing blooms, the grasses and sedges have started to dry out and turn brown. So at this point, it looks like an annual grassland, but it's not. It's not an annual grassland. It's a seasonal wetland. This is our Mount Eddy sky pilot. So pretty. You have to do the grunt work to get up to it because it grows up high. It's up high on Mount Eddy, and it blooms for several weeks in July. That's standing on the top of Mount Eddy, looking east to Mount Shasta. So we are at the edge of the Klamath Range, looking into the Cascades. Penstemon filiformis is part of that group of penstemons that has the horseshoe-shaped anthers, the sacanthera, and there's a bunch of them in the Klamath Range. This one is distinguished by having pedicels that widely diverge from the inflorescence axis. They're glandular. The flowers are relatively small, and the leaves you can see are very skinny thread-like. Also, all these penstemons thrive on intermittent disturbance. One of my favorites, Shoei Ray lardella, is this thing in the aster family that grows generally in or alongside streams, rocky streams. And it forms these big mats of leaves, very, very glandular, sticky stems, and these bright orange flowers. There aren't that many orange flowers, so this is one that's easy to identify. And of course, this is one of my favorites. I got a sedum named after me because I was so frustrated with dealing with rare sedums on the Shasta Trinity and not being able to identify them, because every key, there were 3 different keys to sedums that were in play at the time, and trying to key something out in all 3, you get a different answer in each one. So I hired a group of taxonomists called the Carex Working Group to sort out the sedums, really just on the Shasta Trinity. I was not interested in fixing everything, but they just couldn't stop, and they ended up doing a big monograph on all the sedums in this group called Gormania in California and Oregon, publishing a monograph. Then we rewrote the treatment for the Jepson manual, which was then published. It was either this spring or last spring, I forget. Time kind of morphs these days. Anyway, sedum kiersteadi, it's not rare. It's the most plentiful sedum in the Trinity ultramafic sheet, and it's super cute. Klamath Mountain catchfly, Silene salmonaceae, is part of this group of Silenes that includes Silene hookeri, a new one, Silene nelsonii. They're all these kind of little ground-hugging, deeply divided petals, and mostly in the Klamath range up into Oregon, straying into the Coast Range a little bit. And they like these openings with Ceanothus cuneatus and the woodlands of Jeffrey pine and incense cedar. That's my old dog Buster. Okay, so moving along to the Rattlesnake Creek terrain. This one will be shorter because it's not as diverse. The Rattlesnake Creek terrain is isolated. That's its main thing. It's isolated from humanity. It's isolated from other serpentine areas. Even within the terrain, the polygons are isolated from each other. So there's a lot of island biogeography type things happening here. It's low to mid elevation. There's hardly any water. So the time to visit is in the spring, because by the time summer rolls around, it's 120 degrees and everything's cooked. So typical habitats here are these serpentine barrens, shiny blue, gray, or the woodland on peridotite of Jeffrey pine and incense cedar. There are a few wetlands, but they're tiny. Look at this. You can see the edge of the wetland is abrupt. This one's probably at most an acre in size. Most of them are less than an acre in size. So they don't contribute a whole lot in terms of diversity. But here are a few of the endemics. You'll notice that almost all of these things have changed genus names recently. So I learned this is Madia, Doris nilesii, Niles Madia. It's now a Harmonia. Likes these open chaparral surrounded by conifer forest. Stebbins Madia, also now a Harmonia, grows more on barrens. The pink thing behind it is also a serpentine endemic called Allium hoffmanii, Hoffman's onion. Peanut sandwort Peanut was the name of a town. It was the name of a logging town in Trinity County. That's where the peanut comes from. I think there's still a sign there on Highway 3 that says peanut, but there's nothing there. It just says peanut. So this is in the Caryophyllaceae, the sandwort family, opposite leaves, 5 petals. And the Minuardias, now Sabulinas, they're a bunch of endemics. They seem to do that. It's mostly a plant of these woodlands, the Jeffrey pine incense cedar woodlands. Tubercella buckwheat can grow both on peridotite and on these shiny barrens. It's distinguished by technical characters of the involucre and the bracts. Dubicella is the name of a prominent mountain in southern Trinity County that's part of the Rattlesnake Creek terrain. Ericomeria ophiditis, or ophititis. Ophititis refers to snakes, which refers to serpentine. It's kind of a joke that, it's a botanical joke. Botanists like puns. This thing is a shrub, a subshrub, blooms relatively late, is relatively abundant, but very restricted in its range. And Sedum rubiginosum, this is another new sedum taxon that came out of that sedum study that I just mentioned. It is restricted to a single watershed in the Rattlesnake Creek terrain. It's called the Begum Creek watershed. And it's called Tedock stonecrop because the type locality is on Tedock Mountain, which is the tallest mountain at the eastern edge of the Klamath Range in its southern extent. It's kind of the southeastern tip of the Klamath Range. So far, only, I think, 2 occurrences of this are known, with maybe a third one, not sure about it yet. Okay, so, I missed the map of the Josephine ophiolite. That's the coastal one. So we're moving on to the Josephine ophiolite, closer to the coast and extending into Oregon. This is a large geographic extent, great elevation range, and a lot of different habitat types and the coastal influence. So there on the left, you see a nice Jeffrey pine incense cedar woodland with a seasonal grassland. On the right is a higher elevation headwater situation. Those things coming out of the turf are Darlingtonia leaves. They'll get a lot bigger, but right now they're just little buttons. Lots of high barrens, woodlands, rock outcrops, and lakes. So some of the endemics here, this one is not terribly rare, but you can see how restricted it is geographically. Used to be called a Trillium rivali, and now it's a pseudo-Trillium rivali. Taxonomists, they just keep doing stuff. Very, very pretty little thing. Lilium bolandri. The Klamath Range is rich in lilies. Some of them are rare, some of them are widespread. This one is relatively rare, a list 4, which is limited distribution, but it's not particularly endangered. It's just limited distribution. But beautiful reddish color and more of a flared bell shape, rather not the recurved kind of Turk's cap that Lilium pardalinum and some of the other lilies have. A relatively new species, Silene serpentinicula, one of the red ones that's in the same group as that salmon colored one I showed you earlier. But you can see this one has a distribution that is disjunct from the salmon colored one. This one is limited to the Josephine ophiolite. Vancouveria chrysantha meaning golden flower. It's in the Berberidaceae, the barberry family. It's a cute little genus, nice little native garden plants. This one restricted to the Josephine ophiolite area, and it's a strict serpentine endemic. A really pretty paintbrush, a wetland paintbrush. related to Castanea miniata, which is the tall, bright red one that's pretty common in wetlands inland from here. But this one is either pink or salmon or this, yellow to orange, and restricted to wetlands toward the coast. Grows often with Darlingtonia. And an Oregon endemic to the Josephine ophiolite is Kalmiopsis leachiana, which is a genus in the Heath family, Ericaceae. So it's related to Kalmia. It was named Kalmiopsis because it resembles Kalmia. Also related to rhododendrons and other ericaceous shrubs. And this one responds well to burning, it turns out. This picture was taken not too long after the site burned, and you can see it stimulated flowering, probably because of the flush of nutrients and also additional light because of the removal of the canopy. This one, there's a wilderness area in southwestern Oregon named after this plant. It's called the Kalmiopsis Wilderness. So we'll wrap up with a few serpentine endemics that are shared across several of these areas. Again, reminding you that we have these several different ultramafic areas in the Klamath Range, as well as in the northern Sierra Nevada. Darlingtonia, I don't know if you knew or remembered that. Yeah, it's very common in the Josephine ophiolite area. It's also very abundant in the Trinity ophiolite, and then it pops over to the northern Sierra. It's absent, completely absent from the Rattlesnake Creek terrain. Too low, too dry. So just hasn't made it to any of those little tiny wetlands that are available to it. But I forget sometimes that, yeah, there are serpentines in the northern Sierra Nevada. I'm pretty Klamath-centric. Oops, that one got turned around, sorry. The California lady slipper, Cypripedium californicum, it's another one that's in the Josephine ophiolite, Trinity ophiolite in the northern Sierra Nevada, but there is a little bit of it in the Rattlesnake Creek terrain, and then it kind of dribbles down the Coast Range in the serpentines as well. Porterford cedar is an interesting tree. It has, most conifers are not particularly restricted. This one grows from about Coos Bay, Oregon, down the coast into Northern California. It has a big presence near the coast, and then it kind of skips intervening area and reappears on the Trinity ophiolite. It's a wetland plant. It's at least in the inland part, it's pretty strictly riparian, growing along streams or around the margins of lakes. It's more adaptable on the coasts where, it gets more regular moisture and not as hot. It has a terrible disease that came in, I think, in the 1940s. I believe it's been traced back to import of horticultural plants into Coos Bay that served as alternate hosts for this nasty root disease called Phytophthora lateralis, Porterford cedar root disease. And so much of the Porterford cedar in Oregon is diseased, and it kills the trees. It's a fatal disease. It does allow them, they can grow up long enough to reproduce before they die. So the species isn't dying out. The only treatment for it is to actually kill the trees to keep the disease from spreading. It's waterborne, both on flowing water and in mud, which mostly it's been moved around in mud on tires from logging equipment, cars, other kind of any kind of vehicles that carry mud from one spot, from an infected spot to a non-infected spot. Can even be introduced into a new watershed during firefighting, drafting water to dump on a fire. If you pull water out of an infected area and dump it on an uninfected area, you can introduce it that way. So these days during firefighting, if the fire's in a Porterford cedar area, the tanker or the helicopter or the airplane tank of water will be treated with bleach before it's dumped onto an uninfested area. Very pretty plant, important horticulturally. The English call it Lawson cypress, not Porterford cedar, it's Lawson cypress. So here's a map of the existing root disease. It's pretty much bright red up here in Oregon. I didn't bother to include that, but you can see there's quite a bit of disease over toward the coast in the Josephine ophiolite. Over here, if you squint, you can see there's a little bit along the Sacramento River and one little dot up here, almost, well, this is like Dunsmuir, almost to Mount Shasta. There's Mount Shasta. There was an infested area below Castle Lake that was treated by the Forest Service by killing the infected trees. And that's been 20 years ago, and it hasn't reoccurred there. So we're trying to keep this infestation along the Sacramento River from moving up into the upper Sacramento or the other creeks and rivers that are in the Trinity ophiolite. Okay, so that's all I'm going to talk about plants. Let's talk a little bit about logistics, and if you wanted to go there, how would you get there? So here you are in the Bay Area. The entire area that we've been talking about is in between I-5 and 199. So it's this area here. So the Trinity ophiolite, here's Mount Shasta. So the Trinity ophiolite is right here, west of I-5, up into the Trinity Alps, west of Highway 3. So your best access is I-5 there. Often, you can go in from Mount Shasta. There are roads into it from Mount Shasta. You can take Highway 299 to Weaverville and then access it from Highway 3. Lots of places to stay here, cabins, motels, campgrounds, both in the Upper Trinity River. I've lost my cursor. Oh, well, there it is. Or if you go in from the Mount Shasta side, there's lots of places to stay in Mount Shasta and make a day trip of it. That's easy enough. If you're going to the Josephine ophiolite, which is up here, east of Crescent City and up into Oregon through Cave Junction, the Highway 199 ties Crescent City into Grants Pass on Interstate 5 in Oregon. So you would have your choice of either just driving all the way up 101 and going 199 to get into the heart of it. This is the Smith River in our National Recreation Area, which has a lot of great places to visit. Or you could go up Interstate 5 and access it from Grants Pass to the north. Lots of lodging because there are national parks, Redwood Park, lots of places to stay and places to eat, lots of gas, that kind of thing. So that's not an issue for visiting either the Trinity ophiolite or the Josephine ophiolite. If you want to go to the Rattlesnake Creek terrain, that's sketchier. So access is from Red Bluff or Fortuna on Highway 36 West, which has, I think, Hayfork, which is just, north of there. Last I checked, it had one motel. There are no motels along Highway 36. I think there are 2 places to get gas. A few campgrounds, a few Forest Service campgrounds. There's not a lot of infrastructure to serve you as a visitor. You're probably best off to stay in Red Bluff and make a day trip of it, or be prepared for, camping and providing your own water and food and shelter. And then you go south. I keep losing my cursor. You go south from Highway 36 to the Rattlesnake Creek terrain. So it's down in this area. And the roads, well, this is another graphic of the Trinity ophiolite showing its relationship to Mount Shasta and Interstate 5, Highway 3, the Trinity Alps Wilderness, Castle Crags Wilderness. This is the reservoir, Trinity Lake. And so you would access it via Weaverville and Highway 3, or you would go up I-5 to Mount Shasta and access it from the east. The Pacific Crest Trail goes through the Trinity Ophiolite. All of this, from the Highway 5 here all the way through here to the Trinity Alps, it's all Trinity Ophiolite. So if you like backpacking or just day tripping on the PCT, that's a nice way to access the Trinity Ophiolite. All of these are primarily national forest lands. The Trinity Ophiolite over here is on the Shasta Trinity National Forest, a little bit of the adjacent Klamath National Forest. And you can find flowers from probably late May until September, even early October. The gentians and the asters are still blooming. Rattlesnake Creek terrain is down here on the Shasta Trinity, a little bit on the Six Rivers. Spring flora, you can start finding stuff in March or April, and it's pretty much burnt out by mid to late June. Josephine Ophiolite, you've got a long season, and it's on the Six Rivers in California, the Six Rivers National Forest, and then in Oregon, it's the Rogue River Siskiyou National Forest. And the reason I mention that is because these are remote areas, and Google Maps is not going to help you that much once you get off the highway. These are Forest Service roads. You do well to take a Forest Service map. Some of this, especially in Oregon, is on BLM land. This one, the Siskiyou National Forest map actually includes BLM lands too. But these have the road system, road numbers. It shows the creeks and rivers and the principal county roads. So you should take a good map with you. Paved roads are rare. There are a few. This is one that goes from Interstate 5 up to the Pacific Crest Trail trailhead that goes up to Mount Eddy, and it's chip sealed. Most Forest Service roads, are less than this, or less fancy than this, maybe more fancy than this. This is a 1-lane gravel or native surface road. There's no place to pass. You'd have to back up and find a turnout. I will say that most of these roads, most of the Forest Service roads, especially the ones that are in areas that have burned recently, are graded so that the surface is relatively level and not washboardy or not washed out, because the roads get fixed when the fire is done and the firefighters are getting ready to pull out. One of the things that they do is they go back in and fix the roads, fix the culverts, that kind of stuff. So you don't need a 4-wheel drive. It's helpful to have high clearance. It's helpful to have all-wheel drive. But a lot of these places you can get in a Prius. These are some pretty typical roads. You may have to ford a creek if it's in spring. There are places where the road is kind of washed out and you got to be careful. So just gauge your own comfort level. And please, if you're especially around water, you want to prevent, you don't want to be the person that introduces Port-au-Prince cedar root disease into an uninfested area. So please wash off your tires, wash off your boots, wash off your undercarriage before you go from an infested area to an uninfested area. And similarly, try to not be the person that introduces new weeds to an area that didn't have them before. Yeah, restrooms are few and far between, so act accordingly. This is a brand new restroom as of like 2 years ago up at the trailhead to Mount Eddy. For years and years and years, there was nothing. There was just kind of over under some trees, there was a common use latrine, which was nasty, but I'm glad that there's a restroom there now. Excuse me. Okay, that's what I have to say. There's more information available on this website. This website covers much of the same material in more depth. And it was put together by Lisa Hoover, who at that time was the forest botanist for the Six Rivers National Forest. He has since retired. And the other really great source of information is this book that just came out earlier this year, the Klamath Mountains and Natural History, which covers geology, botany, all kinds of wildlife, as well as native peoples and climate and pretty much anything you can think about the Klamath Mountains. This press, Backcountry Press, is also the publisher of the Wildflower book that I helped write, which was called the Wildflowers of California's Klamath Mountains. So with that, I will take questions if we have time.
Oh, great. Julie, what a wonderful talk. I really appreciated how you had the Cal Flora information and map along with the pictures. That really helps us understand where these flowers are and giving us the information how to visit these places. That's wonderful. So, folks, if you have a question for Julie that she didn't answer in this very detailed talk, just unmute yourself if you can, or put something in the chat, and we can get the mask. Let's see, I have one question from NW. Can you please explain a little more about what ultramafic means?
Well, the word itself, ultramafic, mafic means iron containing. And so ultramafic rocks are very high in iron. There's mafic rocks, which are high in iron, and ultramafic rocks, which is very high in iron. And so I don't pretend to be a geologist. My understanding is just that ultramafic rocks are out of the range of, quote unquote, normal terrestrial bedrocks in the amount of iron that they contain. And also their chemistry includes this anomaly in the calcium magnesium ratio and the inclusion of heavy metals. But ultramafic simply means really high in iron, which is part of is the reason why the peridotite especially has that rusty red color. That's the oxidized iron content.
Okay, that makes sense. Are there any other questions that people would like to ask? Another question that came in the chat. Does relative dryness in non-coastal areas also limit the spread of Phytophthora in the Port Orford cedars?
Yes, absolutely. In the coastal areas, Port Orford cedar can actually grow on open slopes away from the edges of a stream or a river or a lake, whereas the inland ones that are disjunct into the Trinity ophiolite, those are restricted to wet spots, and so they're relatively at less risk, and I think that's partly why they're relatively less infested, is because they are isolated by all of the dryness in between them and the coast, and even in between one stream to the next. And so it takes some discrete act of introduction to move mud or water from one drainage to another in the inland portion of the range to cause an infection. So yeah, the dryness helps.
Yeah, that makes sense. Paget asks if you could switch back to some of the reference materials that you had, sure. the books, so that they can pull that down. Okay, and then I'm going to ask another question. Are many or some of the reclassifications that you talked about based on genomic testing?
Yeah, most of the new names are the result of a researcher doing molecular work and realizing that things that formerly were grouped don't have a common origin. And so for in systematic botany, that's a no-no, because the names, well, the genus names, the family names, et cetera, are supposed to reflect evolutionary relationships. And so if the molecular work indicates that, yeah, these things look alike, but they're not actually related, then somebody's name has to change. That's why the former Scrophulary ace, the family that we all love that had, penstemons and monkey flowers and veronicas and stuff, why it got busted up into, now monkey flowers have their own family and penstemons are in with plantains, and it was all molecular work that indicated that their similarity in appearance did not reflect evolutionary closeness.
Okay. Yeah. It's the modern world changes all the time.
It does. I don't like it any more than you do.
Vicki Wendergartner asks, do Darlingtonias mostly live in serpentine areas?
In inland California and in the Northern Sierra, yes, that's true. And even on the Josephine ophiolite, when you get north, they range a ways up the coast of Oregon where they're not on serpentine. But where they are is on really nutrient poor coastal sandy soils. The thing with Darlingtonia is it's carnivorous because it grows in places that don't have good nitrogen sources. And so these crummy coastal soils are also nutrient poor, and they have to supplement by catching, flies and other insects. So they're not restricted to serpentine, they're just restricted to nutrient poor substrates.
Okay, Yvonne McHugh, she's ready to go to Mount Eddy, and she wants to know approximately how far it is from the trailhead to the peak.
Oh, it's not that far, actually. I think it's like 4 miles. The last bit from Upper Deadfall Lake to the peak is a grunt. It's very, very steep. But most people do it as a day hike. It's about
I've camped at Deadfall Lake many times. It was a good backpack trip for Boy Scouts.
Oh yeah. Yeah, it's a great place. It's a great place to camp. And the trailhead is maybe, I want to say, maybe an hour and less than an hour and a half from the town of Mount Shasta, maybe 45 minutes from the town of Weed. So you can stay in a motel and be at the trailhead in less than an hour. There, I will say around Mount Eddy, the campgrounds, there aren't any campgrounds really. So you either stay in town or there are campgrounds on the other side, on the Upper Trinity River side, and you can go up from the Trinity River up. It's called the 17 Road up to the trailhead. It takes maybe 45 minutes or so. So you can camp on the Trinity River. But if you don't want to stay in a motel, probably the nearest campground would be on the western side of Mount Eddy, down in the Trinity River water basin.
Okay. Bob Maselli asks, how have wildfires affected the terrain?
They've definitely reset the clock on a lot of conifer forests. One of the things about serpentine is it does not have the oak component, the tree oak component that the surrounding substrates do. So things like Quercus calagiae or Quercus garryana or interior live oak or canyon live oak, which are really common all around these areas, as trees, whether they're live oaks or deciduous oaks, they drop out when you get onto serpentine. And so that becomes a coniferous forest, there are understory oaks, in particular huckleberry oak. And what that means is when a fire comes through, it kills the conifers. If it's a hot fire, it kills the conifers. Conifers, with very few exceptions, don't resprout. So you have to wait for them to reestablish from the seed. So what often happens is for quite a long period after a hot fire goes through, you'll have standing dead conifers that then will fall down. You may have resprouting huckleberry oak and other resprouting shrubs, but you'll have montane chaparral for a very long time before there's a forest reestablished. However, there are a lot of annual and perennial plants and shrubs that really enjoy having the canopy gone, and so you'll just get a different flora. When a fire goes through, something like Klamath manzanita would go woohoo. I'm going to flower like crazy, and it will cause the soil seed bank of the manzanitas to produce mass quantities of seedlings. If they're seeding type manzanitas, the sprouters will resprout, and you'll just have a period where you have some bare ground, and you have things like the phacelias will be very happy. The wetlands will still be there. You'll just have to tolerate the appearance of a whole lot of standing dead snags for a while. But I think it's made up for it by the increased flowering in the shrubs and the understory vegetation.
Okay. Gina Picaldo asks, have you identified particular medicinal plants in the areas?
No, I tend to not do that. I'm too wary of the price of making mistakes. During my tenure as the forest botanist, there were a couple of fatalities of people eating what they thought was an edible celery relative that turned out to be poison hemlock. So I don't even the things that I know, I don't talk about them.
Okay, there's a few more questions. Some people are moving on to their next activity this evening. I just want to remind everybody that Julie has agreed for us to put this video on our YouTube site. So if you want to share this video with some of your other friends, or come back and look before you go and climb Mount Eddie, you can do that. In the meantime, Nita and Winter and Rob Badger asked, can you be more specific about elevations? How many feet high? I'm not sure what specific.
So Mount Eddie is the tallest peak in the Klamath Ranges, and it is slightly over 9,000 feet. So, it doesn't compare with Mount Shasta, certainly, but so it's over 9,000 feet. I think the highest peaks in the Josephine Ophiolite are probably closer to 7,000 feet. And the Rattlesnake Creek terrain, I don't think gets above maybe 4,500.
So very accessible.
Yeah.
Yvonne McHugh asks, the three manzanitas that seem to always grow together, do you think it's from a shared mycorrhizal mat?
Oh yeah, entirely possible. Yeah. I wish somebody would do the genetics. I can't see how Klamath manzanita, with its blue-green leaves and its extremely glandular twigs and inflorescence, how that would be the offshoot of a hybrid between two green-leaved non-glandular species. But yeah, I don't really get that. But I'm sure, I have no doubt whatsoever, you're right, that they're all connected underground to each other and to the trees and the other shrubs there. And those areas have, we didn't talk about that. There's a pretty good flora of mycoheterotrophs, the pine drops and things that have no chlorophyll. which are also hooked into the mycorrhizal mat.
Right. All those things that, yeah, are hidden underground. But we're finding out more about them all the time. Well, Julie, thank you so much. This has been a great presentation. We really appreciate it. I'm just going to share Kristen's information again for those that are interested in taking part in our December meeting. And if anybody has any last questions or for Julie, they can put them in. We're just getting a lot of people that have really appreciated the talk. Interesting, wonderful work. Compliments on your great wealth of knowledge. And, oh, your deep voice and sense of tenacious patience. That's wonderful. Well, great.
Well, you know, if something else comes up that you think of that you didn't think of before, you can always just email me and ask me.
Okay, that sounds wonderful.
And I do encourage you to check out Backcountry Press. They've got quite a nice selection of titles relating to Northwestern California.
Okay, Backcountry Press. Great. Well, thanks again, Julie, and good evening to all the rest of you in the chapter, and we look forward to the December 11th meeting. Okay, good night.
Night.